Hi everyone, Sean Zinsmeister here from the Google Data Cloud team, and today I'm really excited to bring to life one of our great customer use cases with Yahoo and how they're using Universal Graph with Spanner and BigQuery Graph with agents to really take their premium digital ad campaigns that used to take weeks, buried in disconnected spreadsheets and endless emails and manual analysis, and really rebuilt this legacy process into proactive system of action. So a look behind the scenes about what we're going to bring to life today using our Cymbal Media use case. It's our fictional publisher, but we're virtualizing the use case to really bring it to life about the great work that Google and Yahoo have been able to do together. Behind the scenes, you're going to see a number of different technologies. The really great thing is to see how Spanner Graph and BigQuery Graph really work together with a universal graph that powers our agents, and really how the Cymbal Media, which is representative of Yahoo in this use case, can help one of their buyers throughout the entire journey. So this is a look behind the scenes of the architecture. It's powered again by two specialized graphs that you're going to see. So let's take a look. All right, so we're going to start by planning a campaign. So we're going to fire off our first prompt here. And there's a number of things that are going to happen on the screen, and I'll kind of walk you through it as we go. So the agent pipeline here on the right just took a few seconds. It's a single GQL query against Spanner Graph. It resolves inventory, live pricing, and target audiences. And because compliance and consent rules live directly in the graph as versioned relationships, governance is evaluated in that same traversal. This really ensures zero hallucinations and also a lot of token efficiency. As you can see that we're offering this token meter here that we built out just to offer transparency, because tokenomics is so important in terms of like, hey, how do we continue to scale out agentic use cases? All right, but now that we've got our campaign planned and activated, as you can see here, how can we audit or explain this decision? So let's actually now look at the CTV prime that was selected. All right, so we're going to run this prompt now. And the agent instantly returns the lineage. So behind the scenes, our explainability agent queries BigQuery Graph to trace the context of the run. So we see CTV prime scored here, while homepage takeover was rejected because its rate violated our budget pacing. So explainability becomes fast. It's a simple database query, not a forensic spelunking log diving expedition, right? All right, but managing operational risk is at the top of all of our enterprises. So let's execute one more prompt here. And we're going to scan active campaigns for policy or consent risks before the weekend. So instantly spins up a governance suite, scans our active campaigns, and flags a particular campaign for referencing an outdated safety policy. It stages a weekend budget reallocation where we have headroom, and then it prepares it for approval. So you can now start to see, like, we are moving from the sort of reactive agents to more proactive risk management in action. And actually, we can actually make this even more autonomous and more proactive by flipping on what we call agentic workflow. And so with this, in the background, the system is now continuously monitoring our active campaigns. So look at the screen. You're going to actually see it's going to kind of walk you through the lineage, and it detected in real time, as you can imagine, a 14% drop, or a percentage drop that we're seeing in our podcast audio segment. So we want to protect campaign efficiency. The agent automatically can pause that underperforming asset and reallocate, driving an immediate lift. That's huge impact that is all kind of governed and transparent. So before making this move, the agent traversed the Spanner knowledge graph to run a real-time compliance check, which resulted in the locked-in governance pass. So the entire trace is committed to the database instantly, and this is a continuous self-optimization, so completely guarded by enterprise governance. All right, so what's making all this tick in the background? So let's take a look first at Spanner Graph. So Spanner Graph layers native ISO standard GQL directly on top of those existing relational tables. There's no duplicated data silos, no ETL. So you can actually watch as I'm going to click the policy consent. It's going to check in one hop. The agent executes a single hop traversal to audit compliance. And traditional SQL is slow, it's costly, like multiple way join, and it's a simple pattern match under like 6 milliseconds. And you're really seeing the power of the scale that Spanner as a multi-model database, high reliance to be able to also offer this like so quickly. It's the best of both worlds with relational consistency and graph flexibility on a single database copy. All right, but transactional databases aren't designed to store years of high volume decision traces. That's why every run is actually captured by our SDK and shaped into a context graph here in BigQuery Graph. Think of it as Cymbal's, in this case, analytical digital twin. So it records every alternative considered, every scoring metric, and every policy version at petabyte scale, really unlocking the power of BigQuery, again, at enterprise scale. So let's actually now run an audit query where BigQuery traverses the graph live to explain the decision behind the session pass. All right. So what we're going to see is we see that the candidate homepage is rejected. So we'll click on this node and we instantly see the precise properties in the detail paneling showing it broke our budget pacing. So best of all, BigQuery Graph connects directly to Spanner Graph live using external schemas in Data Boost, meaning zero ETL. This allows us to join historical decision graphs with real-time outcomes to build a closed-loop learning system for our agents, which feed optimized data back into Spanner for the next run. So let's bring it all together, again, now ending with our architecture here. The architecture on GKE, orchestrated with our Agent Development Kit, ADK, separates transactional operations from analytical memory. And the tokenomics are really, really eye-popping. By replacing kind of brute force RAG with deterministic graph grounding and routing lightweight tasks to Gemini Flash while reserving Gemini Pro for final reasoning, a campaign run uses far more efficient tokens. So this is a huge percentage, 89% cost reduction by this calculation, which makes the systems really viable at enterprise scale. So hope you enjoyed what you saw here. I'm really excited to see what you can build with the Agentic Data Cloud. Thanks so much for listening, and per usual, let us know what you think.